Hi everyone. Thanks for all the interest you've had in my Nintimdo project. It's been a lot of fun developing it and sharing the project with you. I've received some requests to make a video explaining in more detail how I created the device. I hope to answer a lot of those questions in this video, as well as provide some clarification for all the components that go into the system. This video will be a walkthrough of the three main parts of the project. The first being the physical assembly of the case, then hardware population, and lastly, software configuration. You can go ahead and click any of those section headers above to jump to that part in the video. Otherwise, we'll start from the beginning. The first thing you've got to do is get a hold of the case. So go to my webpage, scroll down until you see the 3D model link. Click on that, it brings you to my GitHub, and what you're going to need is these STL files, so go ahead and download them from my webpage. To print your files, you'll have to locate a 3D printer. I'm using a Prusa model that my university supplies to us, and it takes PLA material. I'd recommend using this one. The quality turned out pretty good. Otherwise, if you don't have access to a printer like this, you can always use online tools and pay them and they'll ship you the printed parts afterward. The next thing you're going to need to know to print are the dimensions of the device. The biggest section of it, it's 282.1 millimeters wide and 121.24 millimeters tall. If you have a bed that's bigger than this, you can print the whole device in two parts, the front and the back. If you don't, you'll have to do what I had to do, which was to split it into 4 individual sections and print each of those separately and then put them all together at the end. In the meantime, while everything's printing, go over to the bill of materials page and get a hold of everything on this list. And same goes for the PCB. Click on that link and order one of these. You'll need it later in the hardware section. When you get your parts back, the first thing you want to do is clean them up. Sometimes you'll get some support material in there, so just taking a flathead screwdriver and breaking that stuff off works pretty well. Again, along the top, it's good to clean up where the screen's going to go in. And then once you get that in a good shape, re-drill out the holes on either side of these so that you can stick a metal dowel in each side, and then check to see that they'll join together when you stick that in. If it's a good fit, go ahead and place some super glue along there and then fit these together. On the back side, insert a metal dowel on top and on bottom, and then place super glue in this joint, and along this brace here, and then fit the two halves together. The last step is to insert your joining rods, and these are just female to female standoffs. These are glued into the front panel of the device. The top two up here are 18 millimeters long, and then the middle one, which I don't have on this one, but it's in the final revision, that one is 15 millimeters long, and then the bottom two are 18.4 millimeters long. What you want to do is you want to grind off one end, and then that grinded end, glue it in here with some super glue and Gorilla Glue. Along the way, to test that your depth is correct, you can place them in these holes and then stick the two halves together and see if it makes a good fit. Once you're good, glue them in, and then you should be able to screw in from the back, and both halves should fit together. Before I show you guys the interior of the device, I want to walk around the exterior of it and show you what each of the components are that's attached to it. Everything that I'm going to show you, it's something that you could purchase on that sheet that I showed you earlier. So on the outside, we've got our 7-inch Raspberry Pi touchscreen. Off of the Wii controller that you're going to have to buy, I stripped off each analog stick, the D-pad, these surface buttons, and the triggers. And on the bottom, we have an HDMI out port, a micro USB for charging, and then a headphone jack for audio. On top, I use some of these tactile buttons here to control volume and on-off power levels. And then you've got 2 USB ports here for hooking up controllers or keyboards if you need to. And then here's a fan exhaust, fan intake, and then an LED indicator. Now that we're inside the device, I want to walk through what each component does inside of here. We'll start at the top left. We've got the start and select buttons, and those are mounted to a piece of perf board with 2 tactile buttons underneath, and that happens right here. Under that, we've got the D-pad, and that's 4 tactile buttons for each direction, mounted to perf board again. And the last thing we've got on this side is the left analog joystick. This is stripped from the the Wii remote, and I just cut the PCB and glued it right in there. Moving right, we've got the Raspberry Pi touchscreen. When you stick this screen in, you're going to want to glue it with some epoxy glue and then put some Gorilla Glue over it to seal it afterwards. But when you orient it in, make sure that your cables are on the bottom side of the device. That way the screen's oriented correctly. It's not a huge deal if you do it the wrong way. You can change it in software, but it just makes it convenient to do it this way. This board comes with the touchscreen, so when you get it, you can just mount it to its default spot. On top of that, I stuck the Teensy, which is right here, and that's just raised off a little bit with a standoff and mounted to a piece of perf board so that I could solder all the wires to it. Moving right, we've got a fan which hovers right over the top of the processor, and there's a temperature controller here. My goal was to have the software sense the temperature and then the fan react with a control loop there, but I wouldn't say this is completely necessary to add. It takes a lot of space and you could probably do without it. If you do want to do this, I'd suggest getting a fan that has a side exhaust instead of what I did with the duct system. It might work a little bit better. After that, we've got the home button, and this is for when you're in game and you want to get back to the main menu, you'd press that. Below that is the right joystick, and then we've got 4 buttons here which are A, B, X, and Y, and these are just from DigiKey. It's just its own little unit and you just pop them in. They're really easy. So down here we've got the right trigger, and underneath that is the volume. Those are just tactile buttons I glued in here to a piece of perf board. And besides that, we've got 3-cell battery here. That comes from the Anker charging battery that you'll have to buy. I broke the case open and stuck them in here so that they fit a little bit better. And then this is just 2 female USB sockets that I soldered to a piece of PCB board that I made, and you'll order that. What it does is it extends the USB ports from the Pi out to the case so that I can plug stuff in here instead of having to try and plug stuff in there. After that, we've got this other part of the PCB, which is for mounting the LEDs for the LED indicator, and you just solder those on. I'll show you in a little bit later how to do that. This is the duct, you don't need it. And then we've got the same thing mirrored that was on this side over here for that trigger and then that volume. Down below, this is our main unit. This is the Raspberry Pi 3. I had to strip the USBs off to make it a little thinner so that I'd fit in here. And then those are, again, extended out to this guy right here. Down below, this circuit in here, that comes from the Anker charging. I just moved it over there and then soldered some wires so that it could fit. The audio out on the Raspberry Pi takes this 3.5mm headphone jack to the outlet here, and it's wired there. And then also, when you're not plugged in there, I wired it over to the amplifier here. This is just something you can get off Adafruit, and the amplifier goes to the speakers. So when you plug in, it opens circuits this guy so it's not being used, and all the audio comes out of your headphones. But when you don't have that plugged in, it goes through the amplifier and goes to the speakers. Right here, this is the HDMI out port. It takes up quite a bit of space, so it's not necessary to add, but you can output it to your TV if you put it in there. I have a breakout board here, which is used to charge the battery through this guy, so it's just wired in directly there. And then the output of the battery goes through this, that's controlled by the switch in the back, and delivers power to the Pi eventually. When you take a look at the inside of my device, you'll see different colored wires. I tried to keep it organized and color-coded. My reds are VDDs, and those are 5 volts coming off of the Teensy right here, and those are used to power the active devices. And then all my blacks are grounds, and that's common ground between all these components, the Teensy and the Pi. I linked them together. And then the yellows are used for, I'm using them as signal wires, and those would be for doing like a button press of A. So A would be here. This signal wire goes back to the A button port on the Teensy, and then over the switch to ground. One circuit that's going to need active power is the analog sticks. What you're doing with these is you're reading a voltage level over the variable resistor, and so you have 3 ports for the up and down and 3 ports for the left and right for each of these analog sticks. And usually they have them so that the outer ones are the power and ground, and then the middle ones where you sense. And so on these I have VDD on the outside right here and the bottom here, and then ground on the top and on the left here, and then in the middle I'm sensing the voltage level with these signal wires back to the teensy. And what's going to happen is that variable resistor is going to change, and so as you move the analog stick, you're going to be able to read between 0 and 5 volts and know where your analog stick is positioned because of that. If you mix these up, your stick is going to be backwards because my code is set for how I have it. You can either unsolder them and flip them, otherwise just change the code and it will work out too. One of the most helpful things you're going to find when building this system is to take a look at my schematic. It shows the whole system and how everything's wired. For button presses, all it is just a switch, and you're using it as a pull-down network. And what's going to happen is you'll wire the specific output port from the teensy to the switch, and then the other side of the switch is connected to ground. When you press the switch, it connects the whole circuit to ground and pulls down that pin. To figure out how the buttons work, it's really helpful to have a multimeter and turn it to the continuity setting. You can see for these tactile buttons, which are used really heavily throughout the project, which side is shorted and which side is over the switch. There's 4 pins here. One side of it is going to be shorted together, and you'll know what that is because it beeps. And then one side is open circuit until you press it down, and then it shorts the circuit together. So knowing that orientation, you'd know that you need to wire the pin from the teensy to one of these sides, and then the other side that's open circuit to ground, so that when you press the button down, it shorts the circuit to ground. When you get your PCB, I put 2 circuits on one board to make it cheaper for you guys, but what you'll have to do is you'll have to cut along here to get the USBs off, and then this is the LED circuit. You can make that a little smaller by cutting there. You'll see traces on it. Make sure not to cut through them because it will break the circuit, but otherwise you can shave these down to get them to fit inside the device. For doing the USBs, you'll just have the top part of this, and you'll solder on those female connectors, and then you'll have the 4 different connections here that you have to solder back to the Pi, and those are, it'd be left to right. This one on the left is ground, and then it goes data plus, data minus, VDD, and on the Pi it will be, this will be rotated, so on the right side it will be ground, then it will be data plus, data minus, and then VDD. So it should just be a direct extension out to here, and you can wire those just with regular wire, and you can have a common VDD and ground between these two, but the data plus and data minus need to be unique for each plug. So when you're ready to make the LED indicator circuit, you'll use this part of the PCB here. These pads up here, all 5 of those are for the LEDs, and then these ones are for the resistors, and these through holes are to interface with it. You got ground here in the upper left corner, and then each of these controls one of the LEDs. The circuit just works by putting a voltage on here, it goes through the LED, and then the resistor controls the current that goes through the LED. When you solder these things on, the resistor can go either way, so you can put it on that way or flip it and put it on the other way, but the LED, since it's a diode, it's got a polarity, and you want to make sure that you have the anode on the right side and the cathode on the left side. And if you don't know which side that is, it's handy to take a multimeter and just turn it to your diode setting, or continuity will work too, and put your positive end on the right side like you would when you solder, and your negative side, and if it lights up, you've got the polarity right. If it's not lit up, flip it to the other side and try it again, but make sure it lights up with a positive voltage on the right side and a negative voltage on the left. So after you get all that soldered, you want to go ahead and wire each of those interfacing through holes to the teensy where they need to be plugged in for each of the LEDs, and then after you get that soldered, glue it in so that each of those LEDs shines through the correct hole. To get a voltage level, all I'm doing is doing an analog read from the teensy to the positive voltage level on these batteries, and I have it going through a NMOS transistor here. That's the gate is controlled by this guy as well. And so what happens is the gate is turned high, and then it reads over the source to drain what the voltage is here, and then it shuts it off when it's done. So now I'm going to talk a little bit about the power circuit. I did a little easy one because I barely had any space left when I was about to complete this thing, and all it is just a switch back here. And what happens is the battery output, which is located here, it has a 5 volts and ground. The 5 volts is wired to the switch, and the other side of the switch is wired to the gate of this PMOS transistor. That gate of the PMOS here is also wired to a 10K resistor to ground, so that when I open the switch over here, this guy isn't floating, it just naturally ties to ground and creates a short circuit between drain and source. When the switch is flipped the other way, 5 volts goes to the gate and opens the drain to source. So if you want to turn the device on, you would open the circuit here with the switch to short the PMOS to ground, and then the VDD from the battery flows from it's connected to the source here, and the drain is connected to the Pi so that it can get the 5 volts and power on. Now the ground from the Pi is just naturally linked to the battery. The first thing you're going to want to do for the software section is go to my page, take the link to my GitHub, and then download the code for the project there. After that, you're going to want to open up hardware unit tests, and this is a program to test to make sure you wired everything correctly. Within the Arduino IDE, you should set up parameters to be just like mine so that you can flash the board. If you don't see Teensy 2.0++, go to pjrc.com and download the extension for this program. Now that you have the program loaded on the Teensy, you can follow through the serial prompts on the screen. It will tell you to press down a certain button, and when that happens, you press down that button, and if it works, it says it passes. If it doesn't work, it will time out and say a failure occurred. After that, it will go through a LED test to see if each of the LEDs light up in order, and that's just a visual check for you. And the last check is to see if the analog sticks work. After that test is done, it will spit out the center values of those analog sticks. You're going to want to take those values, put them inside the Nintimdo RP controller board program where I'm highlighting these variables right here. Then go ahead and load the sketch on the Teensy. You can then plug in the USB cable from the Raspberry Pi to the Teensy, shut the case, and power the device up. The first time after you turn your Pi on, once you have the Teensy plugged in, you should get a screen like this to set up the controller. And all you have to do is hold down the A button, and it'll bring you to a menu like this. And on this menu, you're going to link each of the different buttons with the gamepad. So it's asking for D-pad up, down, left, right, start, select, A, B, X, Y. And now for the shoulders, I like to configure it a little bit different. The left shoulder I skip, and to skip something you hold down a previous pressed button, so I'm going to hold down A. Right shoulder, I'll make this button. Left trigger, I'll make this one. Right trigger, I'm going to skip. Left thumb, I'm going to skip. Right thumb, I'm going to skip. Left analog up. Left analog down. Left analog left. Left analog right. Up, down, left, right. And it's all set up. To configure some of the background software, you're going to want to reboot the device and plug in a USB keyboard as it's powering up. When you get to the main menu, hit F4 to get into the command line interface. The first thing we're going to do is remove the annoying lightning overlay. Open up config.txt and scroll all the way to the bottom and set avoid warnings to 1, and then save and exit. Now we're going to set up the trigger happy daemon, which handles all the background button presses from the Teensy. And so the first thing you want to do is install the application, and then you're going to want to open the trigger happy file. Where I'm highlighting right here, make sure that yours is the same as it is in my file, and save and close that. After that, you're going to want to create a file called volumecontrol.conf and put that in the same location that I'm putting mine. Inside that file, copy down the exact same key presses that I have. These will handle, if that key's pressed, it will do the background command, and it will handle backlight and volume and shutdown for you. Save and exit out of that. And then lastly, you're going to want to restart the Trigger Happy service. The final thing we're going to set up is selecting between the Raspberry Pi or the touchscreen. To do this, you're going to want to create a file called displayoutput.sh and put it in the location that I have it, and then copy down the script that I have shown above. Save and exit out of that, and then you're going to want to change the permissions so that it has all of them enabled. Next, we're going to enable that script to run right at boot time, and so we're going to go into RC local, and you're going to add the path to that script in there, and then save and exit. So when the device powers on, it will run that script, check if it's plugged in or not, and then change the settings of where it needs to output the display based on that. Thank you guys for watching. I hope this video explained a lot of how I actually built the device. If you have any questions, please comment them below and I'll try to answer them for you.